yesterday we ended with what were we doing? So we were doing chemical properties. Okay, fine. We have done chemical properties and one reaction, alkylation and acylation is done. Okay. So basic strength I have given question and fine. I hope somebody did the questions. Nazira, maybe, or Amalia, Fatima. Yeah. Assalamu alaikum, Fatima. How are you?
Walaikum Assalam, sir. I'm good.
Okay. So did you get time to do the questions, Fatima?
I just went through them. I didn't do them. I mean, I didn't write them.
Didn't write them. Acha. Okay, let's wait. Let Amalia join. Will Amalia and Nazira, they will be joining, any idea? No idea. Let's wait for 2 minutes, then we can see. No idea, sir. Get idea. I don't think idea works anymore. Okay, fine. I think they are not coming. So, Ms. Fatima, tell me for the first one. How did you do this question?
C6H5NH2 is the least basic.
Okay, first of all, can we C6H5NH2? Okay, fine. Okay. It's the least basic. First of all, we can classify them into 1 degree, 2 degree, something. Na? So the first is C2H5NH2. C2H5NH2. Then I have a PHNH2. Then again we have PH, CH2NH2. What else do we have? We have NH with 2C2H5. Yes, now you can try. Others can also try. In the last class, we did this, na? Basic nature. So in basic nature, we have given some kind of order of basicity. So refer your notes and maybe try, and you can send the answer in chat. Amalia, did you do the questions? Okay, Fatima is also okay. Fatima is joining again.
Sorry.
Did you do these questions, Amalia?
Sir.
No? So, yeah, very good. Yes, Fatima, you were right about the first thing. So tell me after that. Okay, so you're saying acha, D is the most. Okay, fine. So you're saying D is the most, followed by A. Ah, no problem. D, A, then B, and then you're saying C is the least. C is the least. Okay. I think you said it right in the first time that B is going to be the least because this 2 electrons, these are delocalized in resonance. Right? Yes or no? But if I look at these NH2 and the lone pair, you can see that they are not delocalized. They're not in conjugation with the 5 bonds of benzene ring. We have CH2 and we have NH2. So this NH2 is what? This NH2 is completely able to, this is completely localized lone pair. They can easily give these 2 electrons to any proton. That is why it is going to be basic. So B will be the least for sure. B will be the least, followed by, we have also NH3. We have also NH3, I means that NH3. After that, there will be NH3. That means E. After E. After E, so we have done B, we have done E. After E, we can see that I have some A, which is 1 degree. D, this is 2 degree, and C, it is also 1 degree. So now you tell me which will be highest, which will be more basic. Which will be more basic?
1 degree.
1 degree will be more basic. So we have two 1 degrees. We have A and C. Next will be A and C, right? Either A or C, because D is going to be the most basic. So if I see these A and C, how are you going to compare? Here we have sp3. Here also we have sp3 hybridized carbon atom. But if I look at this NH2, here it is having sp3, but these all atoms are what? sp2. These all atoms are sp2. So when you have sp2 hybridized atom, and in sp2 hybridized atom, the hybrid orbitals, they have more s character, and due to this, and due to the more s character, they are going to be more electronegative because s is nearer to the nucleus, and if it is nearer to the nucleus, it is nearer to the positive charge. The electrons are nearer to the positive charge, and that is why they will be pulled easily. So when they are pulled easily, they will be pulling electrons, right? So these all atoms, the sp2 hybrids, they will be pulling electrons, and they will be decreasing the electron density at nitrogen atom. So after E, we will be having C, followed by A, and at last we'll have B. Is this clear, everyone? Yes or no?
Yes.
You understand the difference? Why this 1 degree and this 1 degree? In those two, A is more basic. Why? Because all of these atoms are sp3. All of the sp3 are what? These are less electronegative than the sp2. And here we have 6 carbons which are sp2, which are pulling electrons. And if the electron density is going to decrease, the basic nature is also going to decrease. Is this clear? Abir,
Yes.
Fatima, Acha. Faisal, you know these things? Or how to check the basic character, acidic character?
No, sir.
Okay, fine. So just hang out for a while, Hannah. And maybe we can discuss something after the class if you have any doubts.
Yes, sir, sure.
Okay. So next, what is next? Next is going to be, this we have discussed already, I think, C2H5, C2H5, C2H5. So this is C2H5 1 degree, C2H5 2 degree, C2H5 3 degree, and then we have C6H5 NH2. So if you look at this, yeah, I think this is the question that we discussed. And also here, look, we have discussed this. So C2H5 2 degrees most, followed by 3 degree, followed by 1 degree, and at last we will be having the phenol one. So I can say in this case we will have First will be 2 degree, right? You can check from the notes. It will be 2 degrees. First one will be 2 degree, most basic, followed by 3 degree, followed by 1 degree, followed by PHNH2. Okay, PHNH2. Next, the third one in which we have methyl. Here we have methyl 1 degree, 2 degree, 3 degree. Then we have C6H5. So this is going to be the last, and we have C6H5 CH2. This is going to be second last, I can say. Okay. So the most will be 2 degree again here also, followed by here you will be having 1 degree, right? You can look at the notes. This is the same question in the notes also. You have done methyl and ethyl with different degrees of amines. 1 degree followed by 3 degree, followed by pH, CH2NH2, followed by PHNH2. Okay. Now these reactions, what about these reactions? Both of them will be forming what? Ammonium ions. Now, nitrogen will attack on the hydrogen and it will be forming 1, 2, 3 carbons. So 1, 2, 3 carbons, and then you have NH. It will be attacking on hydrogen, so making a bond with hydrogen. So when we have NH3 with 4 nitrogen with 4 bonds, it will get a positive charge. Here we will get a Cl negative, and this is your ammonium ion. This is your ammonium ion. Here also we have lone pair electrons. They will attack on hydrogen, and they will be forming nitrogen with C2H5 whole thrice with 1 hydrogen, and since it is forming 4 bonds, it will get a positive charge and Cl negative. So this is what this is from, and this is the acidic character of amines, acidic reactions of amines. So whenever you have HCl, any acid, this is going to be base. So we'll do a acid-base reaction, simple acid-base reaction. Okay. So please write this. Let me know if you're done. Done, guys? Yes or no? Just need to make these products, Hannah. I hope you are writing the notes.
Done, sir.
Done. Okay. So let us start today's class. Nineteenth, yeah. Saturday. Okay. So next reaction is simple reaction, carbile amine reaction. Simple but important reaction because it has a name. Carbile amine reaction. Please write carbile amine reaction. Carbile amine reaction. Now, in this, we will be reacting obviously amines and only 1 degree amines. Okay, only 1 degree amines, whether it is aliphatic or aromatic, no matter. It doesn't matter, but it should be 1 degree. It should be 1 degree amine. That is only primary amines. They will be giving carbile amine reaction. They will be giving the carbile amine reaction. Now, if they are giving carbile amine reaction only 1 degree, that means it can be also used as a test. So You can also be getting carbile amine test. What is the carbile amine test? Please write with me. When aliphatic means long chain, or aromatic. Aliphatic or aromatic primary, that means 1 degree amines. Primary amines. When aliphatic or aromatic primary amines are warmed with chloroform. Chloroform means CCl3. With chloroform and alcoholic KOH, they form isocyanide. There, what is isocyanide also known as, or carbile amine. Okay. Important point is that isocyanates or carbile amines, these have carbile amine have very foul smell, very unpleasant smell. So you have R's NH2, which is 1 degree amine. It reacts with chloroform. This will be CHCl3 plus alcoholic KOH. That means alcoholic solution. We have aqueous solution. Similarly, we can also have alcoholic solution. Alcoholic solution means you are preparing KOH in ethanol or methanol, something like that. Okay, any alcohol. Basically, whenever you have alcohol, it is meant to be ethyl alcohol. And when you heat it a bit, that means you just warm it, you will be getting RNC, that is isocyanide, RNC plus 3 KCl plus 3H2O. If you balance this, then you'll be needing 3 moles of KOH, 3 moles of KOH. Is this clear, yes or no? Now, in this reaction also, you can see one thing, that one carbon is added. Here we have NH2. So from NH2, this carbon is just adding on this nitrogen. This carbon is just adding on this nitrogen. The hydrogen is making water from the OH, and these Cl3 is being reacted with this K. Okay. So if you have, let us say, CH3NH2 plus CHCl3 plus KOH, alcoholic condition and some heat, you will be making CH3NC. This is methyl isocyanide, plus these byproducts will be there. Obviously, these byproducts will be there. Okay. Even if you have aniline, that is a benzene ring attached with NH2, you can also see this reaction as CHCl3 plus alcoholic KOH with some heat. You will get benzene. The nitrogen will be as it is, and you will just add a carbon atom here. Okay. So please tell me, is this clear, yes or no?
Yes, sir.
Now, so there are two very distinguishing things: foul smell and primary amine. Okay, and primary amine. Let us suppose you have been given a sample. Okay, you have been given a sample, and they said that this sample contains an amine. You have to check whether it is 1 degree or not. So what you will be doing? You will be doing this carbile amine test. Carbile amine test. So when you do this, so okay, like this is what happens in laboratory now. In laboratories, you don't get a figure like this, right? You don't get this thing. What you will be getting? You will be getting some white colored powder or white colored salt type of thing, and you will be asked whether this has 1 degree amine or 2 degree amine. So what you are going to do? You are going to take that sample. You are going to do the carbile amine test. You will be adding chloroform, alcoholic OH, and heating it a bit. And as a result, what you will be getting? You will be getting foul smell. If you get foul smell, then amine is primary, right? If no, no. If it is yes, foul smell is yes, and if it is no, then amine is either 2 degree or 3 degree. Is this clear? Yes or no?
Yes, sir.
So if you get a question, what test is used? What test is used to distinguish primary
Carbide.
amines? Primary amines from 2 degree and 3 degree. So your answer is going to be carbile amine test. Carbile amine test. What are the reagents? Substrate is going to be any amine, and the reagents for this is chloroform CHCl3 plus alcoholic KOH plus some heat. Okay, plus some heat. Okay. Next is reaction with nitrous acid. Reaction with nitrous acid. Okay, how many of you know nitrous acid? Raise your hand. How many of you know the formula for nitrous acid? Raise your hand. Nobody knows. Abir. Abir, can you turn the mic on?
Yes, sir.
Okay, so if you don't know something, then you will be like, no, oh no, ye to nahi aata, right? Oh no, है ना? Oh no. So nitrous acid is oh no. What is nitrous acid? Fatima, what is nitrous acid?
Oh no. Oh
Oh
no.
no. Oh no, है ना? Faisal, what is nitrous acid?
Oh no.
Oh no. Yeah, very good. Oh no. So it is oh no. It is oh no. Now, you guys don't remember, but it is there in haloalkenes. If you remember something, Ahmed, you remember? I think yes, Ahmed.
Yes, sir.
So in which
Sir,
reaction it is present? Nitrous acid.
so that I don't remember.
That you don't know. So what do you know?
That it is HNO3.
It is not
HNO,
HNO3. That is nitric acid. Oh ho. आप तो हाथ नीचे कर लीजिए आप. It is
HNO2.
HONO. नहीं. This is HONO. Nitrous acid. I've written the formula here. Oh no. Okay, it is oh no. First thing is, how do we prepare this nitrous acid? This is very unstable. This is very unstable. It gets dissociated very easily. So for this, if something gets dissociated or decomposed very easily, then you have to keep it at lower temperature and you have to produce it in situ. In situ means you produce HONO, that is nitrous acid, in a particular reaction container or a beaker by adding some reactant, and then you react nitrous acid at that time only. So freshly prepared, you can say freshly prepared. So you can say first thing is that nitrous acid, that is HONO, is very unstable. Is very unstable. Hence freshly prepared. Hence freshly prepared at low temperature. Freshly prepared at low temperature. How do we prepare it? By adding NaNO2, sodium nitrite plus HCl. And from here you get NaCl, because acid and base. So here you have neutralization reaction, NaCl plus I will be getting HONO. Okay. Now, After this is at somewhere around 0 to 5 degrees Celsius. So when we used to prepare it, we have to get a tub type of thing. There we would get ice like this. And in that ice, we will somewhere here keep the beaker. And in that beaker, we would add NaNO2 and then HCl, then prepare this nitrous acid, that is ONO. Okay. Now, when you have nitrous acid, that is ONO, and you react this with, first of all, let us see how is the reaction with primary amine. So number one, with primary amine. So when you have RNH2 and you react this with HNO2, when you react this with HNO2, then you will be getting, first of all, there will be an acid-base type of reaction. So when you have acid-base type of reaction, you will get R. There will be N2 positive and Cl negative. I think you should remember by now the Sandman reaction. The Sandman reaction here also there will be prepared now benzene disonium salt. It is something like this only, N2 and Cl negative. Now when you have N2 and Cl negative, this is going to be very unstable. When you add this water to it, you will get R OH plus from Cl negative, I will be getting HCl, and N2 will be released as a gas. N2 will be released as a gas. So in total, I can say when I have R, N, H2, R, N, H2, then I will write O, right? Then I will write O, and then I can also write N, O, right? And you are going to prepare ROH plus N2 plus H2O. I hope it is easy to remember for all of you. Yes or no? Please tell me.
Yes, sir.
Okay. So similar type of things will be happening in other cases also. Okay. You have R. So this is primary amine. So let me give you some reactions and you may write the product. You may get it like this: NaNO2 HCl. What does this mean? It means that you are going to prepare ONO. So we will directly write the result. Okay. What are you going to get? So you are going to get alcohol. So what type of alcohol you are going to get? You will just write that.
Sir,
Yeah, tell me.
how did we get Cl in the above reaction?
How did we get?
How did we
Cl?
get chlorine? Yeah.
अच्छा, ये कैसे prepare हुआ है? That is prepared from NaNO2 ना freshly and HCl, right?
Yes, sir. Clear.
Got it? I should have written this here. Okay. CH. First of all, tell me this B is primary amine or secondary amine?
Sir, primary.
Very good. Primary amine only because nitrogen is connected to only one carbon atom. So I hope you guys can make the alcohols.
Yes, sir. Done.
Can you write the names? Can somebody write the name in chat? or A
Yes,
and
sir.
B? Hmm. Basil, can you write the products now for this reaction?
So I'm trying.
Okay. Let me give you for the first one. So what you are going to do, you are going to remove the NH2. Okay, and this instead of NH2, you will be writing OH, CH3, CH2, OH. That's it. Nothing is going to change in the R group. Okay, nothing is going to change in the R group. Nobody has given me the answer. What happened? Yes, Fatima, Amalia, Sania, Nazira. You guys can write the answer, yes or no?
Yeah, so
Yeah, okay. So for B, we will be having, so this is what? This is ethanol, right? Ethyl alcohol, ethanol. And here we'll be getting CH3, CH, OH, and there will be CH3. So this is what? This is 1, 2, 3 carbon atoms, and there is OL group. So this is propane 2 ol. Propane 2 ol. Okay. Right next, that is the reactions with aromatic amines, primary aromatic amines. Okay, reaction with aromatic amines. Reaction of what? Oh no, aromatic amines. In this, we have to write some text also. When aromatic amines are treated with nitrous acid, in cold, that is around 0 to 5 degrees Celsius, 0 to 5 degrees Celsius. When aromatic amines are treated with nitrous acid in cold, they form diazonium salt. They form diazonium salt. This process is known as diazotization. This process is known as diazotization. So I hope you have seen benzene diazonium salt before. That's in haloalkene in the Sandman reaction. The first chapter of organic chemistry, haloalkenes and haloarenes, plus 2HCl plus NaNO2 at some 0 to 5 degrees Celsius. We will be getting the benzene ring will be as it is, and N2 positive, Cl negative, and also we will be getting NaCl plus H2O. So this is benzene diazonium. Now this is chloride, so it will be benzene diazonium. Specifically, it is chloride, benzene diazonium chloride. Okay, so this is important reaction. If you were of the batch, you are a batch what? You are 2022 batch, na? 2021 maybe nahi tha. If you were of batch 2020, I don't know whether in 2020 it was there or not. Don't remember. In 2020, you would have a section in amines of benzene diazonium salt. Complete section was there, preparation of diazonium salt and its reaction, etc. But that part is deleted. So you can get at least this reaction is there. That is one of the preparation of benzene diazonium salts. Okay. So please write this down. Let me know if you're done.
Yes, sir.
So all those secondary and tertiary amines, these are not there in syllabus. Okay. 2 degree and 3 degree amines. The reactions of nitrous acid with 2 degree and 3 degree amines. It is not there, but you can write. If you have R2, that means 2 carbon groups or alkyl groups. It is attached with nitrogen, and there will be 1 hydrogen. And you react this with HO, NO. Then water will be released, and you will be getting R2, which is bonded with N. That means 2 alkyl groups are bonded with N, which is further bonded with nitrogen, and it is further bonded with, okay, wait a second, this will be O, no, sorry, double bond O, plus water you will be getting. Okay, so similarly, if you have R3, N plus HONO, here also you will be getting, first of all, R3, NH, NO2. Then after you warm it, you're going to get the same thing, that is R2N, single bond with nitrogen, double bond with oxygen. This is known as nitrosoamine. Nitrosoamine, that means 2 degree and 3 degree amines give nitrosoamine on reaction with ONO. On reaction with nitrous acid, that is ONO. Okay. So you can write this down, but it is not there in syllabus. Okay. Please remember that 2 degree and 3 degree amines, they are not there in your syllabus. NCERT has just mentioned that 2 degree and 3 degree amines, they react in different manner with nitrous acid. Just that, nothing else. Done, yes or no?
Sir.
Okay. Next is reaction with aryl sulfonyl chloride. Aryl sulfonyl chloride. Next reaction is a reaction with aryl. So that means we will be having a benzene ring, sulfonyl, chloride. So this is also known as the benzene ring, which has sulfur group, the sulfonyl group, and then you have Cl. So this is benzene sulfonyl chloride. Benzene sulfonyl chloride. This is also known as Hinsberg reagent. Hinsberg's reagent, Hinsberg's reagent. Okay. Now the reaction is going to be, I will say, slightly simple here, that you have benzene, chlorine, and you're going to react this with 1 degree amine. So when you have 1 degree amine, that will be having hydrogen. There are 2 hydrogens attached to nitrogen, and there is a R group here. There is a R group here. So when you react these two things, you will be eliminating HCl, that is chlorine from the benzene, Hinsberg reagent, aryl sulfonyl chloride, and hydrogen from the amine group, and you will be forming benzene ring, which has a single bond with sulfur. The sulfonyl group is as it is, and now it has bond with nitrogen. There is 1 hydrogen here, and there is a R group. There is a R group. So you can say that it is N-alkyl. N-alkyl. Then you have benzene sulfone, benzene sulfonamide, benzene sulfonamide. Okay, so maybe the you can see that name is very big, but the reaction is quite simple. Reaction is quite simple. Just remember how you have to write this down. Okay, how you have to write the benzene, how you have to write the primary amine, that is 1 degree amine. Okay, how you have to write the 1 degree amine. Okay, now is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now, when you have this sulfonyl chloride, it is going to be soluble in water. Okay, it is going to be soluble in water. Next, you can write. So this is with primary amine, right? This is with primary amine. Now let us see what is going to happen with secondary amine. So with secondary amine also, it is going to do similar type of reaction. That is, it is going to react with the hydrogen only, because in secondary amine we have 1 hydrogen available. Double bond O, Cl plus hydrogen, nitrogen, which is attached to 1 R group and the other R group like this. So here also we are going to get the HCl will be removed, HCl will be eliminated, and benzene ring with sulfonyl and nitrogen with the 2 R. Now, here what is the name will be NN dialkyl benzene sulfonamide. NN dialkyl benzene sulfonamide. Benzene sulfonamide. Okay, but when you have that, this is 2 degree amine. But when you have the aryl sulfonyl chloride, that is the Hinsberg reagent, and you react this with any 3 degree amines, R, nitrogen, R, and R, it gives no reaction. Why? Due to the absence of hydrogen, attached in the nitrogen. Okay, due to the absence of hydrogen which is attached to nitrogen, the 3 degree amine, it doesn't give any reaction with benzene sulfonamide. And hence we can also say, since amines, these are not very soluble in water, and these things, this is soluble in water. Okay, this is soluble in water. Why? Because this nitrogen, it can interact with the water molecules. This hydrogen can also leave, but here we don't have any hydrogen. That is why it is insoluble. It is going to be insoluble, and for the 3 degree amine, there is going to be no reaction. So here you can also use this test, that is Hinsberg's test, for the distinction of amines. So you can write Hinsberg's test. Hinsberg's test. Okay. Let me just remind you guys from the physical properties. I think last class we did the physical properties. Okay, so you can see If I increase the number of carbon atoms in amines, it leads to decrease in solubility. Okay, it leads to decrease in solubility. So in Hinsberg test, solubility is the criteria that is going to give you 1 degree, 2 degree, or 3 degree amines. Okay, so see, when you have 1 degree amine, okay, and you react this with Hinsberg reagent, so the product that you are going to get, this is going to be soluble in water. Okay, so that means, let us suppose you have been given a sample, and then you have been asked whether it is 1 degree, 2 degree, or 3 degree. So when you have been given a sample and you tested it, and you saw that it is, you tested that with Hinsberg reagent. That means you reacted the sample with benzene sulfonyl chloride, and you got a product that is soluble in water. That is soluble in water. That means you have 1 degree amine. Secondly, if you have 2 degree amine, and you react this with same Hinsberg reagent, you will get a product which is insoluble in water. Okay, so you got a something product. That means whatever reactant you have put, that is not present now. A new molecule is present, but that is not soluble in water. Okay, that is not soluble in water. Now, if you take 3 degree amine plus Hinsberg reagent, there will be no reaction. There will be no reaction. Okay, there will be no reaction. So here you can say that Hinsberg test is used for the distinction of 1 degree, 2 degree, and 3 degree. It is used for the distinction of one degree, 2 degree, 3 degree amines. Okay, so the positive test result for 1 degree amine is that the reaction with Hinsberg test gives a soluble product. For 2 degree amine, what is the positive test? The positive test will be a 2 degree amine with Hinsberg reagent. It will give me something that is insoluble in water. Okay, so do I have to scroll up?
Yes, sir.
Yes, okay.
Okay, then protein
And
plant.
here, who is doing another classes? Huh?
Protein
Ahmed?
plant. Protein plant.
What class you are doing, Ahmed?
Yes, sir.
Yes.
What class you are doing? Are you doing chemistry only, or is someone else there?
So my sister's having another class.
Acha, everyone is studying. Let me know if I have to scroll down.
Yes, sir, you can. Yes, sir, done.
And guys,
Yes, sir.
okay. Next is electrophilic aromatic substitutions of aniline. That means what are those reactions? Electrophilic aromatic substitution. Electrophilic aromatic substitution. The electrophilic aromatic substitutions of aniline. So number 1 point. First thing is that look at this molecule, aniline, aminobenzene, and tell me whether it is a plus M group or minus M group. In the chat. In the chat, tell me whether it is a plus M group or minus M group. Oh, you guys, you don't remember these things, huh? How do we check whether something is plus M or minus M? You know what is plus M minus M? या ये भी नहीं पता है. Abir? Yes, Abir?
Sir, I don't remember now.
You have never heard this plus M minus M.
Sir, I heard before.
You have heard ortho-para-directing or meta-directing. You have heard these things?
Yes, sir.
What about Amalya?
Yes, sir.
You have heard this, na? Plus M minus M.
Yes, sir.
Okay. What about Fatima, Nazira, Sania? Yes, Fatima, you have heard this plus M minus M? What about Faisal?
No, sir.
You have not heard plus M minus M? Okay. So see. First thing is that it is going to be, now you tell me whether it is plus M or minus M. Now tell me, plus M or minus M? किसी कुछ याद नहीं आ रहा अभी भी? This is very bad, guys.
So is it plus M?
Yes, correct, Faisal. It is plus M only. Why? Because it is giving electrons to the benzene ring, na? Right?
Yes.
Yeah. So this is giving electrons to the benzene ring. Okay. So since, let me see what is going to be the resonance hybrid structure for aniline. We have benzene ring like this. Okay. So here we can see all these bonds are sometimes single, sometimes double. That means all of them have partial double bond character. Here we have NH2 group. This NH2 group also has partial double bond character, and we can see that this position is delta negative sometimes, this position is delta negative sometimes, this position is also delta negative sometimes. Okay, so we can say since NH2 is a plus M group, the electron density increases at ortho and para positions. Since NH2 is a plus M group, the electron density increases at ortho and para positions, and that is why the attack also occurs from O and P. That means from ortho and para direction. Please write this down. याद आया कि नहीं आप लोगों को अमल्या, फातिमा? You guys remember now plus M minus M? Nazira? Yes, Abir, Ahmed, Fatima, guys. No, अभी भी नहीं. Hello, am I audible?
I gave the correct answer. Yes, sir.
Okay. What about others?
Yes, sir.
Okay, I don't think Amalya, Nazira, and Sania, they remember plus M and minus. I don't know whether Amalya will remember or not, because but in last year we did this now, yes or no? Also from the like when we started haloalkene, I think we did resonance and all, plus M minus M also we did. But yeah, na, like you will not have been revising the notes now, because haloalkene was long back. I think we did haloalkenes what, last September, I think, or maybe before that also. Did we start with organic chemistry? Ahmed, do you remember? What did we start with?
So haloalkenes and
Haloalkenes only, no? Not solid state.
No,
Solid
sir.
state तो आप लोग को नहीं पढ़ाया गया था. Your teacher said that maybe it can be there in the syllabus, it cannot be there in the syllabus. Okay, I remember that now. So haloalkene was the first chapter. Okay. So the only thing with organic chemistry is that you need to study little and just read something daily with organic chemistry, and it will be fine. You don't have to even sometimes pick up pens. So daily you won't have to pick up pen. Maybe read daily, pick up pen and solve problems once in a week, twice in a week, that will be enough. Or whenever you get some assignment from me, then you solve the problems. Otherwise you have to read it daily. That is the only way you can study organic chemistry, and you can retain many things about organic chemistry. It is hard, but it's not like it's not doable. It's hard only if you don't study small things daily. Write this down. Let me know if you're done.
yes, sir. Done.
Okay. So obviously we are going to get ortho and para products when we have electrophilic aromatic substitutions. The first reaction is halogenation of. First reaction is halogenation. First reaction is halogenation. So in halogenation, we have this reaction with bromine. We have this reaction with bromine in which we have aniline plus Br2 in aqueous condition, or you can also see something like this, Br2 in the presence of H2O. Okay, you can see something like this also. When you have bromine water, you can also see bromine water instead of Br2. Okay, and you will be getting. Now nitrogen is very strong ortho-para directing product. It is very strong ortho-para directing. So you get NH2, and all the ortho and para positions get Br group attached. Okay, get Br group attached. So now what will be the name for this? The name for this will be, we have 1, 2, 3. So this is first carbon, second carbon, third carbon, fourth carbon, fifth and sixth. Yeah, 2, 4, 6. Tribromo Tribromo. Yes, Ahmed. Tribromo aniline. Na? 246 tribromo aniline. Now, this is going to be a problem here, right? Why? Because we are getting a tri-substituted product and we are not getting a mono-substituted product or di-substituted product. So what we can see here, we can write bromination of aniline gives, what is the bromination of aniline gives? It gives tri-substituted product. Now, to get a mono-substituted product, if I want a mono-substituted product, to get a mono-substituted product, we need to decrease the activating power of NH2 group. Okay, so NH2, it is what? It is very activating, very strongly activating group, and that can be seen here. That can be seen here. Okay, also one more thing I should write here, that this is a white PPT. So this can also be used as a test, because if you have a sample, you added Br2 and water to it and you get a white PPT, that means the sample had aniline in it. The sample had aniline in it. Okay, I will write that later on for the test of aniline. Okay, now what we have to do, we have to get a mono-substituted product. Now for mono-substituted product, I have to, we have to distract this lone pair. We have to distract this lone pair. What we have to do, the nitrogen of NH2 in aniline is having a resonance with the benzene ring. Okay, with the benzene ring. Now let us suppose if I add some group here which can have a double bond. Now if it has double bond like this, then what I can do, this now lone pair is distracted. It's sometime it will go this side and show this type of resonance. At other times it will go here and it will show this type of resonance. Yes or no? Can you see this happening?
Yes, sir.
Right. So what we have to do, we have to decrease the activating power. That activating power is coming from the lone pair of NH2. Now, to decrease the activating power, we will distract the lone pair. Okay, we will distract the lone pair. Now, let us review the reactions of aniline. Okay, reactions of NH2, how we can add, how we can replace this H2 with something single bond. You should have something like this, na, NH. This will be having some single bond A with a double bond B. Okay, we have to add this group. Can you see this? Yes or no? Amalya, Fatima, Nazira, all of you?
Yes, sir.
Okay. Okay. So I'm not giving you the what are we going to do in this reaction and what are we going to add. Let us review the reactions of amines, and let us fetch up one of the products. Will that be fine, all of you? Yes or no? Please tell me.
Yes, sir.
Okay, fine. So I need answers from everyone. Amalya, Fatima, Nazira, and Sanya. What was the first reaction that we saw in the chemical properties of aniline? Sorry, not aniline, sorry, for amines in general. Amines, tell me. What was the first chemical property? What was the first chemical property? Yes, Amalya, Fatima. Look at your notes and tell me, na. Are you not there, Amalya? Yes, Amalya, tell me.
Aliphatic amine and ammonia.
Can you be a bit louder?
Aliphatic amine and ammonia.
Aliphatic amine and ammonia. Okay, that was the first reaction. That was the first chemical properties. No, you have to see in chemical properties. What is the first chemical properties? You have not written the notes, Amalya.
Sir, I wrote the notes. Basic character of amine. Sorry.
Okay, fine. So in basic character of amines, we will be reacting this with acid, right? Yes or no?
Yes, sir.
So if I react this with acid, let us say HCl. So this lone pair will react and we will be getting RNH3 positive. Okay, so just remember what type of fragment we need here. I hope you guys understand. We need a fragment in which nitrogen is bonded with some atom A and that atom A has a double bond with B. So we need this fragment in the product. Are we getting that fragment here? Tell me yes or no. Are we getting this type of fragment? Yes or no, tell me.
Yes, sir.
Yes. Okay, so
No,
where is
sir.
the double bond?
No, sir.
अरे भाई तो ऐसे कैसे? Yes, sir. What is the next reaction then? Tell me. What is the next reaction of amines that we did? Chemical properties में. Fatima will tell me now. Fatima, tell me. Otherwise, you are not present today. Fatima, what is the next reaction that we did?
Alkylation.
Very good. Alkylation. What was the reagent? Look in the notebook and tell me. We had amines and then
Rx.
Rx. What is Rx? What is Rx? What is X there? Tell me, Fatima. What is X? X is a variable.
Yes.
Wow. Wow, my oh my god, Fatima, yeah, X. What family is represented by X, Fatima? आपने कह दिया variable, तो yes. Math चल रहा है यहाँ पे.
Bromine iodine.
हाँ, halogen. What is that? Halogen. You sound like you're sleeping.
No, sir.
हाँ, very good. So we have Rx. What is the product? Tell me. Let us say this is R dash. What is the product? R bonded with
NH.
R, NH, and then
R dash.
R dash. So tell me, are we getting this type of fragment that we need?
No, sir.
No, na. You must compare करना है. I hope like I don't know whether you have not seen newspaper and all, but like slightly before your time, before 2014 and all, after 2014 there was a, I don't know what type of internet we have now. So before 2014 there were newspapers, and in newspapers there were columns. Maybe you may have seen that, and like this, and you have to find difference between these two pictures. Have you seen those? Yes or no? Tell me.
Yes, sir.
Yes, sir.
है ना, तो वही करना है यहाँ पे. You have to just compare things. Okay, you have to just compare things. So these are meta skills that you should have. You should see that you should be able to see the difference at least. What is the next reaction? Tell me. अगला reaction क्या था? What was the next reaction?
Acylation.
Acylation. What was the reagent? What was the reagent? What was the reagent? Oh my God, what happened? Reagent नहीं पढ़ने आ रहा आपको? Right? You don't know this reagent? Let me write the name. This is acyl chloride. Okay, and this is anhydride. So it's acylation, or we can say acetylation, depending on what are the reagent you are using. Now, what we can do here, you can see that we are getting R, N, H with single bond carbon with double bond O, and there is some group attached with carbon. Yes or no? Something like
Yes.
this?
Yes, sir.
Now tell me, we are getting our desired fragment? Yes or no?
Yes, sir.
right? We are getting our desired fragment. So this is the reaction we will do. And after that, we will be reacting the product of acetylation or acylation with bromine water. So let us see what is going to happen. First of all, we will have aniline, that is RNH2. Then we will react this with, so a better product is formed if you react this with acetic anhydride. That means you are going to have C double bond O, C double bond O. Okay, so this is acetic anhydride. Now, here you will be getting this benzene ring as it is with a nitrogen, with a hydrogen, and this nitrogen will be having a single bond carbon, which has a double bond oxygen and a CH3 group. So here we have done acetylation, right? Here we have done acetylation. Now we are going to add Br2. Now we are going to add Br2. Now this nitrogen, the lone pair here, it is distracted. It is sometimes going towards the carbonyl carbon and it is sometimes going towards the benzene ring. That is why we will be getting only two, we will be getting two products and two different products. And both of these products will be mono substituted. So this is the reagent, sorry, the substrate that we had. So we'll get a Br in the ortho position, plus we will get a Br in the para position, two different products. And both of these are what? Mono substituted. Both of these are mono substituted product. We'll get a Br here. You're going to get a Br here. Now, here obviously, this is going to be a minor product because there is some steric hindrance here, due to which the Br will not be able to attack so effectively in the ortho position, and the para it is what completely, it is not sterically hindered. We have so much of space here, so this will be major product. Now we have to convert. These are known as, this is, let me write here, this is okay. Now we have to convert these into amines. We have to convert these into amines. You just need to react them with H plus in water or OH negative, any type of workup you have to do, and you will be getting NH2 Br. Oops, यहाँ पे हम ये लिख देते हैं, sorry. Here I should write the ortho just to be consistent. Here I should write para just to be consistent. And here this will be minor. This will be major. Okay, so please write this down. Let me know if you're done.
So this is H2O and H plus. Yes, it is.
Or you can also use H2 in the presence of OH negative. Guys, yes or no?
Yes, sir.
So now just you can write it, because theory may also you can get this type of question. How can you get a mono substituted product if you react in the bromination of aniline? So what you will write, we have to get a mono substituted product by decreasing the activating power of NH2. So for that, what is done? To decrease the activating power. Please write this with me, okay? Power of NH2 group acetylation of aniline is done which forms, yeah, okay, Abir, no problem. Which is going to form acetanilide. Now, in acetanilide, the lone pair of NH2 is in conjugation with benzene ring as well as the C double bond O group, Okay, so you can show it like this: nitrogen with a hydrogen here and a carbon, C double bond O, and there is some R group, whatever R group is present. Here we have taken CS3, okay, here we have taken CS3. You can show that there is a resonance like this happening. Now this lone pair is not available to benzene for a while, and this is now C double bond, C single bond O negative, and there is R. Due to this, the lone pair is less available and the activating power decreases. Okay, activating power decreases. Activates the ring and controls the reaction to get mono substituted product. Term to date sheet is not out yet, huh? Or is it out? Yes. Yes, Abir Amalya.
What did you say?
Is the term to date sheet out now?
No, sir.
No. Okay, fine.
So
Write
there's
this
a
down.
term will start from 26 April.
26th.
April
26th.
26th or 8th. I will check and see.
So 26th of April exam will start, but like we don't know until like what exams and what day.
26th of April. Oh my God.
Yes, sir, they have delayed it.
Okay, that means I am going to get students. है ना? वो आखिरी वक्त वाले होते हैं बिल्कुल. Okay, fine. Faisal is not that one because Faisal had some classes and right now he is not getting any class. Circular came on February 9 from CBSC. Okay. यानी कि okay, fine. So you guys remember आपको अपना 11th standard याद है आप लोगों को? फातिमा, अहमद, सानिया. At what time? Little. At what time you started the classes and when was your examination?
3 months before.
3 months before.
No, sir, 1 month before.
You started in the mid of December, you guys, है ना? And your examinations were from February.
So I guess I started 1 month before.
You started, okay, maybe you started from January, but Fatima was there, na, from starting, Fatima in 11th standard.
No, I joined in 12th.
Actually, you joined in 12th. So who was there? Fatima was not there.
Mari-
Nasra was also. Mariam was there.
Yeah.
And Sania was there. Sania, were you there from the starting?
No, sir. I joined at 12.
12. But Abir
Yeah.
was there, na?
Yes, sir.
Abir was there, but Abir joined late in 12th standard. Right, Abir? Little late, not much late. Okay. Fine. By the way, did Mariam tell anything? Why is she not joining the classes? Amalya?
She's going to another chemistry class.
Another chemistry class, like in Bahrain only.
Yeah, it's both
Oh.
offline and online.
Acha, it's both offline and online. Okay, got it. She used to initially, like in 11th standard also, she used to take 2 chemistry classes, I think. Okay, fine. So is it done, yes or no?
Yes, sir.
Okay. So you will get this PDF, na?
Yes,
And
sir.
you can write this 13.11. This is from NCERT, and I just need to cross out a few reactions here. Those reaction is this reaction and this reaction and this reaction. Yeah, these are the benzene disonium salt reaction. Others you can do. Try to put effort. Okay, try to put effort. For example, I know that right now you can't identify this reagent, right? Or can you identify? Fatima, tell me. Can you identify the reaction?
No, sir.
Not right now, है ना?
Yes,
लेकिन ये
sir.
अभी क्या है? देखिए, what is CH3CO? CH3, C double bond O. Then you have oxygen here, right? This oxygen has 2 of these groups. Fatima, we just did this reaction, na? है ना? So
Yeah,
थोड़ा like just put some effort, okay? Put some effort. You will get all of these reactions, okay? चलो. So let me just